Hi, I'm Alex, and today I want to show you how to make your system observable with Coroot. But before we dive in, let's talk about what observability actually means. Basically, it's about being able to answer questions about your system. How's it doing right now? What was it like an hour ago? And are there any errors? And how fast is it handling user requests? And the most important part is that if something breaks, you need to figure out why fast. And that's where something called root cause analysis comes in. Coroot makes all of that easier, and it's an open source observability tool that uses eBPF to gather telemetry data automatically. That means you don't need to mess with your code or set up any complicated integrations. You just install Coroot and you're good to go. Let me show you how it works. Let's start by heading over to Coroot's service map. This is our demo application. It's just made up of a bunch of services that talk to each other in their databases, and this is the map that Coroot built for us. You can see how the services are interacting in real time, the number of requests between components, latency, errors, and traffic. And let's take a small look at the indicators in each app name. Coroot already checked every app for errors, latency, availability, CPU, memory, network connectivity, logs, and other details. So let's click on the catalog service and see what's going on. First of all, we see the service map, but now it's focused on our app. On the left side, we have all the clients that interact with the catalog service, and on the right side, we see the services that it depends on. This way we get a clear view of how this particular service fits into the bigger picture, and it's really helpful when you're trying to understand the flow of data and how one service impacts the others. Next, let's dive deeper into the app performance and see what Coroot tells us about its current state. Now that we're on the SLO tab for the catalog service, we can define what we expect from the service. So for availability, we want it to serve 99% of requests without errors, and for latency, we expect 99% of requests to be served in less than 500 milliseconds. So right now, both metrics are looking good, and there's no significant errors or slow responses. And if you want to adjust these expectations for any service, it's super easy. Just click on the threshold and you can set your own. And here's the best part is Coroot detects a significant SLO violation, it'll automatically send you an alert. So you can receive it whenever it's most convenient for you, whether it's Slack, Microsoft Teams, or another alerting channel. Below that, we'll see a list of clients interacting with the catalog service. For each client, we get requests per second, latency, and errors. And the Heatmap below will show how response times are distributed. It's easy to spot any spikes or slowdowns. We also have requests per second chart, an error rate chart, and a latency breakdown with percentiles. This makes it super easy to track performance over time and see if any issues pop up. And that's it for the SLO tab. Quick and clear insights into how the service is doing, with flexibility to set your own performance goals. Now let's check out the Instances tab. First, we see two quick checks. Instance availability, which tells us whether or not instances are up. In this case, it's okay, because we used to have 75% running. And restarts. This shows if any containers have restarted recently, and right now, also okay. No restarts detected. Below that, we see a list of all the catalog service instances. For each one, we can see statuses, whether it's running, IP address, where the instance is located, and a note, which Kubernetes node it's currently running on. And all instances are up and running smoothly. And at the bottom, we have two charts. An instance chart, which shows the number of running instances compared to what we expect, and the restarts chart, which tracks and restarts over time. And since it's empty, we're good. This tab is great for a quick health check to see if your service is properly scaled and stable. Now let's check the CPU tab. At the top, we see two quick checks. Node CPU utilization is one. Shows if any nodes are overloaded, and right now, it's okay. No nodes are above 80%. And the container CPU utilization tells if any containers hit their CPU limit. It's also good. No issues here. Nice touch is that Coroot only shows the relevant nodes, so even if your cluster has 1,000 nodes, you'll only see the ones that actually run this app, which keeps it clean and focused. Tab has everything you need to check whether the app has CPU-related issues or not. For example, your app might lack CPU time if it's hitting the CPU limit, or the relevant node itself might be overloaded. Now let's look at the chart. The CPU usage shows how much CPU each container is using. The CPU delay tracks if containers are waiting for their CPU time. Node CPU usage gives an overview of CPU usage on the nodes running the service. CPU consumer shows which processes are using the most CPU on a specific node. These charts help you quickly spot any CPU bottlenecks or resource issues. Now let's focus on the memory tab. First, we have two quick checks. Out of memory, which shows if any containers were killed and running out of memory. Right now, it's okay. No OOM events are detected. And a memory leak tells us if memory usage is growing too fast, more than 10% per hour. Again, it's okay, so no signs of a memory leak. Just like the CPU tab, Coroot only shows relevant nodes here, so if your cluster has thousands of nodes, you'll only see the ones that actually run in the app, which keeps it clean and focused. This tab is really useful when you're trying to figure out if your app has memory-related issues like unexpected memory growth or containers being killed. And now let's look at these charts. Memory usage shows memory usage RSS of each container in the catalog service. Memory usage looks stable, no spikes or unusual growth. And the node memory usage displays the memory usage on relevant nodes. Memory consumers break down memory usage by process on a specific node, and it just makes it easy to see which apps or services are using the most memory. With these charts, you have everything you need to check whether the app has any memory issues, like memory out of memory or memory leaks. Now let's move on to the network tab. At the top, we see 3 quick checks. Network round trip time, making sure the RTT to upstream services is 10 milliseconds. It's good, no latency issues there. TCP connections, so checks for any failed connections to upstream services. Also good, no problems detected. And network connectivity, verifies that all the upstream services are reachable. It's good. This tab is great for spotting network-related issues that might impact your app, like connectivity problems or high latency. If we check out the charts, we can see network RTT shows how long it'll take to communicate to upstream services. Looks stable. TCP connection latency tracks how long it takes to establish a connection. Active TCP connections displays the number of open connections, and TCP connection attempt shows how often the app tries to connect. Failed TCP connections highlights connection failures, and there's none here, which is good. And TCP retransmissions track how often packets are resent. No spikes, so it's a good sign. Traffic shows inbound, outbound traffic volume, which is steady and consistent. These charts help you quickly see if your app has any latency issues like connectivity drops or high latency. Now, if you want to head over to the DNS tab, Coroot captures DNS queries made by each app, so you can easily see which domains were resolved and check for any errors or high DNS latency. This is super useful because DNS issues can definitely impact application performance. At the top, we have 3 quick checks. DNS latency, which makes sure the 95th percentile of DNS response time stays below 100 milliseconds. Right now it's okay, and there's no latency issues. DNS server errors check if any server-side DNS errors, including NX domain, is okay, which means there's no errors detected. And DNS NX domain errors verify that there's no unexpected NX domain errors, which is good. Next, we see result domains and the number of requests made to each one. This helps you understand which domains your app are actively interacting with. So let's take a look at these charts. We have the DNS request by type, which shows the rate of different DNS query types, like A and AAA, and DNS errors highlight any errors per second. And there's empty here, so no issues. DNS latency displays the response time, included P50, P95, and P99 percentiles. So if you see spikes here, it could mean DNS issues are affecting app performance. These charts help you catch DNS-related issues like slow lookups or failed resolutions that could be slowing down your app. Now let's head over to the Logs tab. Coroot's agent automatically discovers and collects application logs. What's really cool is it also identifies the severity of each message, so you can immediately see which logs are informational and which indicate problems. Coroot makes it easy to spot issues by showing a log volume chart, where errors and warnings are highlighted in different colors. You can also filter logs by severity or text using the search bar. Coroot also extracts repeated patterns from the logs, which means you don't have to analyze raw messages one by one. Just click on patterns to see the type of errors grouped together. This way, you get an overview of the most common issues without digging through tons of log lines. Below these charts, you'll see log messages sorted by time, and you can quickly scan through them and focus on critical ones without getting overwhelmed. This tab makes it log analysis way faster and more manageable, especially when dealing with huge amounts of data. Now let's talk about how Coroot can help you get a clear picture of your services, even if you're dealing with hundreds or thousands of them. The application health summary is designed to make it easy to see which services need your attention. It shows your apps based on severity, so you always know where to focus first. Here's how it works. At the top of the list, you'll see apps that are violating their SLOs, or service level objectives, either because they're throwing errors or performing too slowly. These need your attention straight away. And next, you'll see apps that are performing within SLO limits, but still have some issues. Think of these as situations that need your attention during the day, but they're not critical right now. And then after that, you'll find apps that don't have SLO or performance issues, but still have errors in their logs. And at the bottom, you'll see apps that are running smoothly with no issues detected. This way you get a clear, prioritized view of your entire system. Instead of digging through hours of logs and dashboards, you instantly know where to focus your efforts. Now let's talk about one of the coolest features in Coroot Enterprise Edition, AI-based root cause analysis. First, let's check if there's any anomalies in our service performance, and we have a latency anomaly. Let's drill down and see what's going on. Coroot has already done the hard work and identified the root cause. You can see the issue propagation path showing how the problem started and which services were affected. In this case, it looked latency issues starting the DB main database and propagated through the catalog and order services, eventually impacting the front end. Coroot doesn't just stop at finding the problem, it also gives you a summary of key findings and root causes. In this case, it detected high CPU usage, increased network latency, and I/O performance issues on the DB main instance, causing a cascade of latency spikes throughout the service chain. You can also use Coroot's AI explanation feature to get a detailed, human-readable breakdown of what went wrong and why. You can just click Explain with AI, and Coroot will generate a summary of the root cause in plain language. This is a game changer for troubleshooting because you get both the technical details and a clear explanation, helping you fix issues faster and minimize downtime. Let's talk about the cost analysis and how Coroot makes it easy to understand your infrastructure costs. Coroot's agent can automatically detect when a node is a cloud instance on AWS, GCP, Azure, or other cloud providers. It uses the cloud metadata service to identify details like the instance type, region, and whether it's a spot or on-demand instance. With this information, and knowing the pricing model for major clouds, Coroot can calculate cost for each node. What makes Coroot really useful is it can calculate the cost of each application based on its actual resource consumption. Instead of just seeing how much your nodes cost, you get a breakdown of how much each application is costing you. Handy, right? Since Coroot monitors traffic between applications, it can also calculate across A to Z traffic and internet egress costs, broken down by application. This is super valuable because in some cases, traffic costs can actually be higher than compute costs. And this level of detailed traffic cost analysis is something you're not going to find in your cloud billing reports. And if you're running your workloads on bare metal servers or in air-gapped environments or on private clouds, Coroot still has you covered. And the best part is you get all this without any extra effort. Coroot doesn't need to be integrated with your cloud account or billing API. It just works out of the box. And that's it for this demo. We covered a lot today, from service maps to SLO monitoring to cost analysis and the PI-based root cause analysis in Coroot Enterprise. Coroot makes observability simple and effective, helping you catch issues faster and understand the root cause without getting lost in data. Whether you're running microservices, databases, or stateful apps on the cloud or on-prem, Coroot has you covered. And the best part is it's open source and self-hosted and doesn't require any complicated integrations. Just install it and you're ready to go. Thanks for watching. Check out Coroot at Coroot.com and see how it can help you improve your observability and reduce downtime.